17 years. It is present in pretty much all LED light sources to a greater or lesser extent. So it is something that we should be considering, really depending on the application, though. And it can generally be split down into the following. So we have visible flicker. So again, we've probably all seen that, even if it's just on TV. You can occasionally see it if they're displaying another monitor in the background or somewhere, or fans and light, for instance. You can. So this is visible flicker. It says it's the modulation of light, whether it be periodic or intermittent, and which most users can see as a change in light output, even under static conditions. We also have invisible flicker, so that would be flicker at a higher frequency, which is not perceivable in terms of vision, but actually can have some health effects. And then we have stroboscopic flicker. Again, we've all probably come across that with rotating machinery or moving machinery, and this is the periodic modulation of light due to the characteristics of the power source being used. So if that's got some ripple current there or some flicker on, as most drivers do. Here we can see the picture there. This is a LED panel with showing 100 Hertz flicker. And the various root causes and visibility of that. Root causes can be the actual light source technology and its driver topology. So whether that be fluorescent lamps and the old magnetic drivers, or now obviously LEDs with electronic drivers. Dimming technology, of course, that could have a bearing on that. What type of dimming technology are we using? Can have quite a large effect on what flicker we see, and also mains fluctuations. That can have a bearing as well as things like mains dimming. So any phase dimming could be very noisy in that respect. And then some of the factors that determine actually the visibility of TLA's temporal light artifacts, things like frequency and relative magnitude of the ripple itself, the shape of the actually the waveform, whether it's square or sinusoidal, for instance, the lighting levels and background lighting, for instance, can have a bearing, and then the stroboscopic effects, the speed of movement, and the sensitivity of the observer themselves, and the things like the viewing angle and the changes in direction of view when you move yourself, and as I said, the background light level within the environment. So these can all have a bearing on flicker and stroboscopic effects. So here we can see it's a pencil just moving about 25 Hertz, I think it is, around about there. But the effects of flicker can range from decreased visual performance, for instance, to actually non-specific illnesses, and in really bad cases, the onset of epilepsy. So it's all been documented. It can also affect animals as well. Studies with cats have shown even 100 and 120 Hertz flicker has shown the firing of cells in the part of the brain that controls eye movement, for instance. Bigger issue, certainly issue that we tended to find with inquiries about Flickr was more to do with other equipment, and specifically photography and video equipment, and to a lesser degree things like barcode readers, scanners. So that was the big one in the early days. Fortunately, that's to a greater degree or pretty much gone away now. Fortunately, and that's because of a change that we've made in the driver, the operation of the drivers themselves. Now, it is possible. I mean, I did some short experiments on the bench regarding flicker and current ripple with camera system or video system, and it's quite interesting because I found that even with a driver with a high ripple output, I could see the flicker there quite easily when I was recording at 24 frames a second. But if I moved to 25 frames a second, it completely went. And it turns out that as long as your frame rate is a divisor of the frequency of the ripple or the flicker, then it shouldn't be a problem. So there are ways of getting around this in camera systems, in video systems. But that certainly was we had much more inquiries regarding those sort of issues than we ever did with sort of health issues, let's say. Now, pretty much all light sources have some sort of flicker, and it's apparent to a lesser or greater degree. Even at incandescent lamps have a flicker, but however, because of the thermal mass of the filament, it's large enough for this to have actually virtually no effect on the light output. So hence why we don't see anything from any flicker or ripple at all from incandescent lamps. As I mentioned before, fluorescent lamps with old magnetic style chokes, again they emit flicker at 100 or 120 hertz depending on your mains frequency. So, and this can be quite noticeable. So, but that was cured by changing to electronic ballast at a much higher operation frequency of the lamps. So that completely went away then. So onto LEDs. Now, of course, the flickering LEDs is different to other light sources, really because of their extremely fast response times. Typically, a couple of nanoseconds an LED can respond in. So very fast. So pretty much any variation in the current or especially the current that you pass through an LED will cause a change in the light output. And that's what we need to obviously try and keep to a minimum. And that has changed over the years. New driver designs have decreased the current ripple out of the drivers. So it's becoming less and less of a problem now. It is possible, I've never seen one, but it is possible to make drivers or LED drivers with completely stable DC outputs, but it's all down to price, unfortunately. They will arrive at some stage, but not at the moment. Now the effects of flicker on human animals really does depend on the flicker frequency. For instance, headaches are mostly associated with light modulations higher than 100 hertz. So this is beyond the visual range generally of perception. However, measurements of electroretinograms of indication that even up to frequencies of 200 hertz, they can still see responses to 200 hertz of flicker as well. Turns out that the maximum sensitivity is around 15 hertz. People do suffer from things like migraines, tend to be sensitive to flicker at, let's say, the higher frequencies. And there has been even stroboscopic effects that have been reported at 500 hertz, so that's quite high. But say the biggest issue that we come across was with, as I mentioned, with high frequency flicker is with camera systems. Wave shape itself also does have an effect on it. So we perceive different wave shapes differently. Here we can see a couple of graphs. So we have a graph on the left. Now this is the threshold needed, and it was actually a group of 10 people to be able to detect flicker. And I'll put my laser pointer on, you can see it. You can see here, so this is maximum sensitivity, around 15 hertz. And the graph on the right is the same data, but as plotted as sensitivity. So again, we can see most sensitivity is around about the 15 hertz limit. What's interesting is obviously that virtually nothing above 60 hertz. So this is really the range that we are most sensitive in terms of any flicker modulation. In terms of LED drivers, they've changed over the years, but we do have a ripple current on the output. So we have our DC output, and there's always some slight ripple current there. So you can see it here, somewhat exaggerated, but and that over the years has diminished. So we've got drivers that have got as little as 2% ripple current, maybe 5% is about the norm. As I said, this will eventually come to zero, but it's really all about cost. There is other higher frequency outputs from drivers that can be in the region of sort of 80 to 100 kilohertz, but of course they really are they're not perceptible at all. Really, again, they only potentially create problems with video and photography equipment. The big change in driver design came about from changing the dimming output from drivers from PWM, pulse width modulation, which we used to use, now to amplitude modulation. So all we're doing now is changing the output current. So dimming the output current up and down to change the dim level of the LEDs, and not pulse width modulation, where we were essentially switching the output signal on and off at about 500 hertz, which created its own issues. In terms of flicker measurement, there's a couple of ways you can do this, and we'll come to the document in a minute that has this. But we can have this flicker index that is area 1 divided by area 1 plus area 2, and we can have a flicker percentage that is calculated with this. However, there's a big problem using that because they don't take frequency into account. So you could have a higher frequency with a higher flicker level that is less of an issue, less of a problem than a lower frequency with a higher or a lower level flicker index or flicker percentage. So this is the real problem with doing it this way, is that the frequency isn't taken into account. In terms of flicker metrics for common light sources, so here we see the old incandescent lamp, very small percent and very small flicker index. Up massively higher with the old compact fluorescents with magnetic ballast, and then with electronic ballast, much lower. And then again with HID lamps, so metal halide and high pressure sodium, very high. And I assume that was actually with magnetic gear again. And then down to LEDs. So if we are actually supplying with a direct current, very low for LED, but LEDs with significant flicker can be very high. So it's all about the driver. So the output from the driver. The LED itself doesn't really contribute anything to these levels. It's purely the output from the driver. So again, back to the output from the drivers. So these the analog and the PWM dimming. So if you're not familiar, so here we have our analog or amplitude dimming, where we just change the output current level to dim the LEDs, or with pulse width modulation, we are switching the signal off and on, and depending on the mark space ratio, depends on the power we're supplying to the LED, so that'll dim it in that way. Now the big problem that is, of course, we are physically switching it on and on, so we've got all these on and off states that can be a problem. The reason for PWM dimming was it was the best method of dimming LEDs due to LEDs shifting color slightly when you dim them. Now you can see here the red trace here is the color shift of an LED with PWM dimming, and the green trace is with amplitude dimming. So you can see the green is slightly more. However, this is all within a 1 McAdams ellipse. That's very low, so it's just not possible really to see that difference. So hence why the move to amplitude dimming, because it got rid of all the problems associated with PWM dimming. We don't have the switching on and off. It's all now, we're purely changing the current through the LED. It's also improved compatibility with video systems, for instance. We're not having the switching on and off anymore. So much fewer problems now that we've moved over to amplitude control, and also that the most drivers now have actually very low output ripple. Here we can see some effects of PWM. Really, we see the stripes on the board there. So this is the interference seen with camera systems. and it does get worse depending on your dim levels. Of course, with amplitude dimming, we don't have any of that switching, so it gets rid of it completely. One of the things that you shouldn't do, and we get this quite a lot, or we used to get it quite a lot, is people sending in us videos that they've taken on their mobile phones, showing how bad their lights are flickering. And yes, they are. They will do that because the ripple in the UK is at 2 times main frequency out of a driver. Mobile phones tend to operate at 30 or 60 frames per second. So here we have an incompatibility there. If you're using 25 frames a second, PAL, you don't see it. If you use that same mobile phone in the United States, where they have 120 hertz flicker, again, you won't see it. But here you will. It's 30, 60, it's not a divisor of the flicker frequency. So hence why a lot of people think they've got really bad flicker because they're viewing it on their mobile phones. The reality is they haven't. They can't perceive it in any other way. So never use mobile phones to see how bad your light flicker is, because it'll look terrible. One of the more recent documents we've seen is this IEE 1789, so it's from 2015. And this obviously comes from North America. And this again is really recommended practices for LEDs with trying to mitigate the health risks of use. Thing to be said straight away is it's not a standard of any description, so there's no compulsion to comply with this. However, it's used a lot. This document is used a lot in tenders. So essentially, you do really have to comply with a lot of it. And basically, it's quite a ranging document. I think it's about 80 pages long. So if you're really bored one day, have a look. Well, there's some interesting stuff in there, to be fair. So things like sources of flicker and different ranges of flicker and things, biological effects it could cause in people. So malfunctioning fluorescent light can cause EEG problems with patients and headaches, eye strain, for instance. And then we can have even fully functional fluorescent with magnetic devices, magnetic chokes, can have enlarged saccades over text. And a saccade is small movements of both eyes in when you're scanning text, so it can increase that movement. It can be an issue just for reading. Now, really, what the 1789 recommends is certain levels, maximum levels of current ripple, let's say, or flicker, and generally that's, if you're looking at up to about 90 hertz, it's approximately 8%. So here we have different regions. So the green region is where you should be no risk, and here we have a slight risk, but generally of 90% below, it's not a problem. Good quality drivers now are below 5%, so they shouldn't be an issue anymore. So here's the recommended operating area, and depending on the frequency and it does change, of course. So here we have a lower value in this region here, then up to 9% there or above, depending on the frequency. So generally we're down at around about 5%, around this sort of mark, and there's generally not problems anymore. I don't ever hear of reported issues anymore at all. People are quite cautious about this, say when they're specifying parts, and I think they're familiar with it now as well. They know parts that work in certain applications. So we have a few recommended practices that come out of this document. So here you can see below 90 hertz, that's 0.25 times the frequency. 90 hertz above, so approximately 8%. So that's one, and then we have again much lower rate there. Tends to be the recommended practice one that people tend to adhere to, because that's quite easy, fairly easily achievable by most drivers. Null on this is no observational effect level. And then, so TLAs, you may have heard the term, so temporal light artifacts. Excuse me while I just have a drink. So these are basically undesired effects in the visual perception of an observer within an environment, such as flicker, short-term light modulation, which is given the term STLM, or stroboscopic visual measurement, so SVM effects. Now, this is fairly new. This is actually came in, I think somewhere. Yeah, so this actually came about in October 2019, but wasn't made mandatory until September 21. Now it's actually only mandatory for mains driven LED light sources with inbuilt power supplies. So it's not mandatory for any LED drivers, as long as they're not built into the LED itself. However, it's likely probably that it's going to be taken up for all light sources. So we certainly comply with this now. And there's just a brief method here of actually how we measure it. So this is a measurement of the output of the basically of the driver. So so we have a light sensor there, and then essentially the eye-brain mine. Essentially, with the end, we won't go into details of it, but we have this PLMS ST measurements. Now the limit for that is equal to or greater than 1. And if you look on the driver data sheets, you will see these values, PSTLM and SVM, and they will just show you that it's below the limit. They won't actually give a specific value themselves. So in terms of regulation supply, so we just mentioned that. So this is only really for LEDs with inbuilt drivers. So that's it. That's a sort of a fairly brief overview of flicker, some of the problems that we've had in the past. Fortunately, doesn't really rear its ugly head very much now. Very, yeah. So I've only had one person in 17 years that I'm aware of that had some health problems. I know it's generally not recommended. Certainly, Health England don't recommend, for instance, having pulse width modulation, but the industry's got away from that now. So yes, so fortunately we seem to be going on the right route, and problems have been diminishing. Certainly, we don't even hear very often now of problems with other systems like camera systems or barcode scanners, these sort of things. So thank you very much.
All right. Thank you very much, Richard. Hopefully everybody can hear me.
Yes.
First, I just introduce myself. Hiya. My name's Sonia Pepperell. I'm the SLL representative for the West Midlands, and we've obviously, as part of the SLL and CIBSE West Midlands, we've obviously asked Richard to come and speak to us today. So thank you very much, Richard, for that. First, we just want to apologise for the trouble that we had, the technical difficulties at the beginning of the presentation. However, hopefully we've still got people on here who obviously can join us, and hopefully everybody's been able to hear and see the presentation correctly, so as it should, which is fantastic. So fingers crossed, hopefully. Just going through a few of these questions then, Richard. So obviously we've had some comments here throughout the presentation with people's experiences. So people have been commenting on their experiences here with Flickr, some of the complaints that they've come across. So you said that you hadn't come across too many. So there's a few more people have said that they've come across one or two instances. Flickr with webcams as well. So some software has been mentioned that there could be some software to obviously help deal with this, to help with Flickr over webcams, because of course, like today, we're sitting here using webcams to obviously present this CPD to you, and of course, health conditions as well. So those are all things that's been mentioned. We do have a couple of questions here. First of all, are there any lighting design templates that can deal with this, can help deal with this?
Not that I'm aware of, but then I'm not really the right person to answer that, because it's not something I get involved with on the lighting design. It wouldn't at all surprise me if there were, but yeah,
Okay.
I'm not familiar with any.
Fair enough, fair enough. I guess from a lighting design perspective, it's all about choosing the luminaires and then choosing the quality and understanding the components within that luminaire, I guess, in terms of making sure that they are using the correct drivers, the correct, good quality drivers, good quality components, and a reputable luminaire manufacturer, I guess, should cover those automatically. You've mentioned about the standards. So of course, here in the UK, all luminaires should be designed to those standards. So hopefully, if you get a good quality, if you're purchasing or specifying a good quality product, then not only to do your lighting design correctly in terms of distribution, but also quality of that driver, then hopefully that should eliminate some of these issues that we've been speaking about. Is that a fair assumption?
Yes, absolutely. Yeah, I mean, having the right, especially the right drivers, is very important, because they will vary depending on the quality of the driver. Yeah, everything from a few percent of ripple or flicker up to much higher levels, depending on what you want to buy. So really, you've got to choose the right components for your application, basically.
Yeah. Yeah. So we had another question here then. So it says, you stated high frequency flicker, so potentially causing non-visual effects such as migraines, can be due to other driver components. They're asking, could you please elaborate on this? I.e., does it depend on manufacturers and cost? I think we've just briefly mentioned that.
Yeah, it's down to components, and it's down to the design of the drivers. So one manufacturer's drivers could be quite different in terms of what output frequencies there are on their basically on their outputs.
Okay. And then so we've got here there was a note here that just whilst you were talking. So exactly what is the cost differential to provide a driver that fully mitigates?
Again, I'm not the right person for that. I really don't know. Suffice to say that if it wasn't significant, we'd be doing it already. The problem is, say it is possible, but if we did it, nobody would buy our drivers at the moment. We're a very cost-sensitive market in the UK. So yes, whilst it is possible, yeah, they would be more expensive, unfortunately.
Okay, fair enough. That's fantastic. Well, if anybody else does have any questions, please feel free to, we just had one through, yeah. So just please feel free to use the chat function here on the right-hand side. So we're getting a few in here now. So is there any regulations or standard is there any regulation or standard mentioning the requirement for designing street or road lighting using LED luminaires? Is there any regulation or standard mentioning the requirement for designing? There is, in terms of lighting levels and things like that. I think if everybody looks in the chat, then Brendan has kindly put a link to the fact file in there for temporary lighting artifacts. So obviously that's something that people can have a look at. But with regards to regulation or standard monitoring for designing street lighting or road lighting using LED luminaires, there are, of course, the SLL Lighting Guidance. Do you have anything to add there, Richard, with regards to specifically maybe for road lighting or street lighting?
No, again, not that I'm specifically aware of, just the general guidelines.
Okay, yeah. So I'd probably recommend that people go and have a look at the SLL guidance. So we have lots of SLL documentation on the knowledge portal, and that they can be downloaded there. So you can have a look at the exterior lighting, the road lighting aspects of that. Okay, so we've got another question here from Benjamin James. He says, camera flicker, so when we're talking webcams, etc., can be helped, as said in the presentation, by the flame rate being used. Most webcams will allow the change of the recording frame rate, changing 24 to 30 FPS. Can require third-party software, but it is a consistent issue that there are solutions to this, but there are solutions to the problem. So I think that's just a note there for reflickering.
Yep.
Okay, lovely. Can I just ask, so if there aren't any other questions, so please, as I said, to bring those in. Richard, do you have that beginning slide there with the QR code on?
Yes.
If you could go up to the very top, I think it was at the beginning there. So I just want to say to everybody, thank you everybody for your time today. If you do have any other questions that you want us to answer, so please feel free to email them to us. If you want to know more information about the SLL, then we can have a look at the website, which is www.sll.org.uk, or you can contact us at sll@cibse.org, and then that should be, or you can always speak to one of the local representatives, and obviously we can help there, so no problem at all. Hopefully, so on the screen you'll be able to see just Richard's kindly putting up for us. This is a QR code that we've put together. If you wouldn't mind, this is just a QR code to link you to just a feedback form, just to give us some feedback, if you can, on today's event, but also what you'd like to see in the future. So for future CPDs or seminars, if there's any particular topics that you'd like us to cover, then again, if you wouldn't mind, that would be fantastic. CPD certificates, we can send you the CPD certificates after, as well as a link to the presentation after the event, so you should get those on an email. QR code is no good to me, and a filter be fitted. Okay, all right, fair enough. So give that a go. Any problems, please let us know. But otherwise, I just want to thank everybody again for joining us today, and my apologies for the technical issues we had at the beginning. So thank you very much, Richard, and thank you everybody for joining us.
You're welcome. Thank you.
No problem.